Hey guys, we are working on part 2 of your semester exam review today. So if you want to open up your Delta Math for me, please. Okay, I'm coming into your semester exam review, part 2. Okay, remember all of these are going to be due by the end of the school day on Monday. Okay, there won't be any exceptions to that, especially since I'm gone. If you finish early, then you are welcome to go back and work on any old any old homeworks that you haven't gotten around to yet. Okay, so I'm going to start off here. We're just going to kind of skip around. Let's start with number 1. We have a step function here. So it says, what key attributes describe the step function? So the first one is that the function is increasing. Okay, this answer choice is pretty bad news. And the reason why is because it kind of does look like it's increasing. Okay, but increasing means that it has a positive slope, that it's pointed like this. Okay, and so unfortunately, although it is composed of many line segments that are eventually going like that, that is not the same as actually increasing. This is wrong. Don't pick that. Okay, there's a question just like this on your exam. Okay, a step function does not count as increasing or decreasing because each of your things are flat. That is not considered an increasing function. Just like if it were going downhill, okay, that would not be considered decreasing. Next question says that the domain is all real numbers, or the domain is all real numbers for letter 2. Okay, well, you got to think about which letter is which. Domain is X, so that means that having it matched up with a Y here in the third answer choice, that cannot be right. Now, let's talk about, is the domain all real numbers? Well, okay, think about my graph. I have a closed dot here, and then as I move over, I have an open dot, but then it's filled in directly above it. So even though I don't have a dot here at -2, I do have one here. And then as I trace across, I have an open circle, but then right above it is a closed circle. So what ends up happening is that as I get to these open circles, I jump up a step, hence why it's called a step function. Okay, so your domain on this actually is all real numbers. Okay, that actually is the correct domain, even though it is kind of weird because it jumps around and stuff, that is correct. Okay. Last one says that it is symmetric to the origin. Symmetric to the origin means that you could spin that function basically around and like rotate it 180 degrees. So think about for a second if I were to do that. I think actually that would end up also being true. So symmetric to the origin basically means that if you rotate it around, so if I take this dot right here and I spin it around 180 degrees, that would put me right here. Okay, but no. If I didn't really look at this ahead of time. If I take this dot, which is here, and I spin it around 180 degrees, it would have ended up here. So this is not symmetric to the origin. Symmetric to the origin would be like if you had, let's say your graph was like this. Think about like a fidget spinner. If I were to rotate that around 180 degrees, okay, this part of the curve would be in its exact same position, and this part of the curve would be in its exact same position. That's what it means to be symmetric to the origin, is that you have a 180 degree symmetry. Okay, which you can see here obviously does not happen. Okay? So that one would be my function does not count as increasing. The domain is all real numbers. It is not Y is all real numbers, and it is not symmetric, so it would be 2 only. All right. Let's see. Let's go to discontinuity here, first one. Okay, so we have an equation. It says find all places where the function is discontinuous. Okay, so remember there are two types of discontinuities. Okay, the first one is when you have a hole, and the second one is when you have a vertical asymptote. The difference is that for a hole, it's going to cancel in the equation versus a vertical asymptote does not cancel. Okay, but either way, you're going to have to factor the top and the bottom to see where that happens. So, set up my little t-chart over here. I want a negative 12. I could do 1 times 12, 2 times 6, or 3 times 4. I want a plus 1 in the middle. So I know it's going to be 3 and 4. I'm going to put the minus on the 3 to keep the 4 a little bit bigger so that 4 minus 3 gives me that positive 1. So I have x minus 3 on top, x plus 4 on top. Okay, now I'm ready to go to the bottom. So on the bottom, I have a t-chart again, negative 21. I have 1 times 21 or 3 times 7. Those are the only two numbers I can think of. Okay, then look in your middle here. I see that I want to have a 4 left over. So if I want a plus 4, that means I need to do 7 minus 3. So I'm going to have an x minus 3, and I'm going to have an x plus 7. Okay, holes are the terms that cancel out. So I see that I'm going to have a hole in the graph at this x minus 3, which means that it's going to be an x equals positive 3. And then anything else that's going to give me an x on the bottom of 0. So that means that I'm going to have a vertical asymptote at this x plus 7, which is going to actually be x equals negative 7. So my answers would be positive 3 and negative 7. And it looks like perhaps both of those are answer choices. So I think I see 3 here, negative 7 here. Also keep in mind that your review can be in different orders, so just kind of keep an eye out for that. I don't know if you got the same version that I have, but there are a couple different versions for the answers. So remember, a discontinuity could cancel out or not, but if it makes the bottom 0, then that's going to be it. Okay, take a look at your next graph. Okay, so I went into this question here. Says end behavior of square root, and I'm actually going to do the first one. Okay, so if you want to see the title of it again here, it's end behavior square root. So it says we're doing end behavior. So the first thing that you should notice is that end behavior, your x has to be headed towards the end of the number line. So that means that x has to be approaching infinity, because if x were approaching negative infinity, I would have been over here, and there's not even a graph over there. That doesn't even make sense. So automatically, I can eliminate x approaching 0, gone. Okay, what are my other options? X approaching negative infinity, gone. I don't even have a graph over there. And then is there one more down here? Let's see. So we know it's not A or C. Okay, so there is another option that we have to consider. So it's not A, it's not C. Okay, so look at your two options that are left. This says as x approaches infinity, either y is approaching infinity or y is approaching negative infinity. Well, remember that those two options have to do with which way this end up here is pointing. Okay, so if I'm trying to look at the end of this graph over here, okay, I notice that it is pointed up. So as I approach this far right end of this graph, as my x gets closer and closer to infinity, okay, which is this end of the graph, I can see that I'm pointed up, then I'm going to want y to approach infinity. Okay, y approaching negative infinity would mean my graph was pointed down, but I can see that it's pointed. Also remember, it doesn't matter what happens in the middle. Okay, you're only looking at the end behavior if x is going to infinity. Okay, let's see. Let's go to vertical asymptote behavior. I'm going to go into the first one here. Okay, so it says the graph of a rational function is shown below. Which statement describes the behavior around the vertical asymptote? Okay, well, we should know that the vertical asymptote is going to be this line right here. Okay, that's straight up and down because it's vertical. So the first thing I'm going to do is I'm going to label it. That's going to be x equals -5. As I approach my asymptote from this side, I can see that it's aimed down towards -infinity. But as I approach from this side, I can see that it's pointed up towards +infinity. Okay, so remember, all that you have to do is identify which side is the left and which side is the right. Okay, so I'm going to do that in blue here. Okay, this is the left side of the graph, which means that x is approaching 5 from the minus side. Okay, because it's the left side of that asymptote. Versus over here, I'm on the right side of that asymptote, which means that x is approaching 5 from the positive side. And I would want to get a -infinity. Versus on this side, I want a +infinity because it's pointed up. So just kind of think about that for one more second. This line that I'm highlighting in yellow, okay, that's the vertical asymptote. So if you're on the left side, you're an x to the negative. If you're on the right side, you're an x to the positive. And then if you're pointed up, it's a +infinity, just like end behavior. And if it's a -infinity, then you're pointed down. So let's read through our answer choices, see which one makes the most sense. And unfortunately, I'm going to have to erase this because I can't really see my screen. So it says -5 from the left, y is going to -infinity. Okay, well, if I'm on the left side and I'm going towards my asymptote, I can see I'm pointed up. So I know that that has to be incorrect. Okay, I can tell that on the left side, I am not going down. I can see that I'm going up. So that is wrong. That was supposed to be an L for left. Okay, let's look at part B. So A is wrong. B, -5 from the left, y is going to infinity. Okay, well, that makes sense because I am actually traveling up on that side. So B is looking good to go. Now look at C. C says, as I approach -5 with a little plus, that means that I'm doing the right-hand side. Okay, then my y is approaching -infinity, which is down. So then I just look at my graph. Is my right side pointed down? Okay, well, yeah, it is. As I approach that dotted line, which is right here in the middle. So as I get closer to it, I can see I am pointed down. So that means that B and C are both correct, which means that I would be looking for 2 and 3, which would be this one. And remember, be careful about positions, okay, because they can kind of flip around on you based on what form of the review you have. Okay, let's see. Even or odd, we should remember. I'll go ahead and go into the first one. Okay, so I'm in the first, odd or even. Says the graph of 4 polynomial functions are shown above, or are shown. The graphs represent a polynomial with an even degree. Select all that apply. Okay, so remember that even degrees, your ends should be going the same way. Ends same way. Okay, versus for an odd graph, your ends go opposite ways. Okay, even graphs, your ends go the same way, versus odd graphs, your ends go opposite ways. So if I want even, I want the same way. Well, then this one, I see both my ends are pointed up. This one, they're pointed opposite ways. This one, they're both pointed down. I want that. This one, they're both pointed opposite ways. So that means that I would want graph 1 and graph 2. So looking at my answer choices, I want 1 and 2. That means I want this one right here. Okay. All right. Last one. Let's do irrational attributes of functions. I'm going to click on the very, very last question on part 2. Okay, remember, you can always graph these. You could do it by hand, but I'm going to just go ahead and graph this one. So it's 4 over x minus 1 minus 2. 4 over x minus 1 minus 2. So I'm going into y equals here, opening up my fraction, x minus 1, and then I think it was a minus 2. Yes, minus 2. Okay, I'm going to hit graph here. Okay, the first thing I notice is that it seems like I have a bit of an asymptote. Now I'm going to try to draw kind of on my calculator screen here. Okay, but it looks like it's about right here. Oh, that's bad. Hold on. Okay, it looks like it's about here. Okay, now I can't perfectly guess from the graph, but where I can guess from is from the table. So it looks like it's at about maybe like 1 or 2. So if I come into my table here, do you see how at 1 I have an error? Okay, that tells me that this thing that happened here, that was at 1. Now, the other thing that I can do is look for any other errors in my graph. So I'm going to scroll down first. Looks pretty normal. Scroll up the other way, see if I see any other ones the other way. Okay, looks pretty normal. Then that means that x equals 1 is probably the only thing that is weird going on in this graph. So I can see that my graph is going this way and then this way. Now remember, there's not only horizontal or vertical asymptotes, there's also a such thing as a horizontal asymptote. So if I draw a line in here, you should be able to see that you have also not only an asymptote at x equals 1, okay, but we also have 1 at whatever this value is here. Okay, so I'm going to try to count it on the graph here, but it looks like maybe it's at -2, maybe -3. So let's look at I'm going to put y equals -2 question mark. Okay, and then I'm going to come over here to my delta math, and I'm going to check out my answer choices and see which one looks like it makes sense. Okay, so my x equals 1 was my vertical asymptote, and y equals -2 was my horizontal asymptote. So let me write that over here. So I had x equals 1, and then it was y equals -2. Okay, and then my graph looks like here and here. Okay. So first one says the domain is -infinity to -2 and then -2 to infinity. Well, the first thing that I notice is wrong with that is that -2 is a y. So that shouldn't have anything to do with domain. Domain should be an x. So I can eliminate A, okay, and I can eliminate C, because both of those put -2, which is a y value, into the domain, which makes absolutely no sense. Okay, if -2 is a y value, it should be with the range. So I automatically know it's either B or D. Okay, then let's check our y's. This one says -2 and -2. Okay, the biggest thing that I noticed here, and this is a tiny little detail, look at the endpoints on your domain and on your range. This top one, for example, let me write it bigger, is -infinity to 1 with a bracket. This one down here is -infinity to 1 with a parentheses. Okay, think about which one of those is right. Okay, if I have an asymptote, that means I absolutely cannot touch that value. So I should not have a bracket on it. That does not make sense. That means that it has to be D. You cannot put a closed bracket on an asymptote because that breaks rules, right? Okay, having a bracket on an asymptote means you actually have a value at that number, which would not be true if there's an asymptote there. Okay? So that would have been D for that example. All right, so you have the rest of class to finish day 2 of your review. And then next time I see you, we'll be doing part 3, and then you will be finished. So keep it up, use your time wisely. This is a test grade, and it should be pretty easy to get finished. You do have the videos turned on, so just a quick reminder, if you get to a question that you have no idea how to do, then you should actually, I guess for the teacher created ones, you might not be able to do that. But go back and look at your homeworks and their videos and stuff on there, plus all your notes. Okay? All right, you can do it. Best of luck to you.